Cárdenas, muchísimas gracias que estás aquí con nosotros. Un abrazo de donde estés. Y pues bueno, vamos a leer un poquito sobre ti para que te conozcan y pues para que posteriormente pasemos a tu presentación. Ella es Alma Cárdenas, ella es profesional en tecnología y sostenibilidad con amplia experiencia liderando la transformación empresarial y digital para las empresas globales. Desde el 2010, Alma ha liderado programas globales de innovación en Microsoft para la adaptación de la nube, servicios financieros, estrategia de sostenibilidad, contabilidad de carbono y cadenas de valor de abastecimiento responsable. Su carrera de ingeniería informática de ella giró hacia la sostenibilidad en 2018, ¿sí? Cuando se unió en el, perdón, es que me están escribiendo, espérenme tantito. Es que no puedo leer bien porque me están proyectando aquí otra. Ok. A ver si lo logro ver. Ok, dice, continuó porque dice su carrera de ingeniería informática de ella giró hacia la sostenibilidad en 2018 cuando se unió al equipo de sostenibilidad ambiental de Microsoft. Entonces, ese es un poquito de su larga carrera que tiene ella, pero pues igual ella nos va a presentar algo sobre vulnerabilidad y el futuro de los ecosistemas. Ella nos va a presentar en inglés, entonces pues igual también para recordarles que no se les olvide en cuestión del idioma, por si gustan escucharla. Entonces, muchísimas gracias, Alma. Continuamos contigo y te cedo la palabra. Muchas gracias.
Muchas gracias y es un placer poder estar con ustedes y compartir un poco de mi trabajo. Déjenme iniciar mi presentación en... ¿Pueden ver mi presentación?
Correcto. Sí, yo ya la veo.
Nada más que tengo que irme hasta el principio. Perdón. Debería de haber. Ahora sí. Muchísimas gracias por la invitación. I am going to switch to English now because I have been living here in the US for more than 30 years. My Spanish is a little bit rusty. But I am so happy here to talk about one of my favorite topics, which is the role of technology to help us understand vulnerability and future of our ecosystems. I wanted to set the context about the forest services that humanity uses, right? We could not live without forests. And I just wanted to highlight that a recent study by WRI has come to the conclusion that forests today help us absorb 7.6 gigatons of CO2 from the atmosphere every year. Just to give you an idea, humanity right now, it's pumping 40 gigatons, and about 20% of that is being absorbed by the forests. And not to mention that they clean the air we breathe, and they provide for clean water that we drink, and also provide habitat like the monarch butterflies here to 80% of terrestrial ecosystems. So we really need to do all we can to preserve these important ecosystems. Forests have been under pressure for a long time. Ever since humanity invented agriculture, we have been turning forests into agricultural lands. Today, we have modified about 50% of our land ecosystems. So the pressure has been there. What is new nowadays are the pressures that are coming to forests for climate change, which is what I want to address in this presentation. And I just wanted to mention that deforestation is not the same all over the world. We are seeing, for example, in the tropical regions, more deforestation due to land conversion for agriculture. And in the temperate regions, we are seeing a lot of deforestation from wildfires and logging. I just wanted to take one little step here to let us know and remind us that we all can take action. I think looking at this graph and understanding how agriculture affects and deforests our forests, we need to really consider changing our diets from animal-based to plant-based. This is some small action we can take today to help preserve the forests that provide us so much. But now advertisement is over. Technology has been helping us understand forests for a while. And we heard in the past presentation, the great example on how Global Forest Watch is the perfect example on how we have been using technology to help us stop or understand deforestation. Technology nowadays is helping us create high-resolution digital inventories of our forests, where we can get to the tree level, understand tree species, understand tree heights, for example. We can use earth observations and machine learning to help us monitor wildfire or predict deforestation. We can use computer vision, for example, to help us detect diseases in forests. Nowadays, with the investment in forests for carbon offsets, we are using machine learning and earth information on biomass to help estimate the carbon stocks of forests. And we are going to be seeing a lot of technologies emerge to help us understand the climate and nature risk to forests so that we can manage it. These technologies are not quite easy to develop and deploy. We have to have multidisciplinary systems, experts that know about ecology, forestry, computer science, remote sensing, image processing, computer vision, distributed compute. So everything we can do in the technology to make the technology easier to use and understand will be a good effort. Microsoft launched the planetary computer effort back in 2020 precisely to try to do that. And it is to democratize the access to Earth observations and provide a platform for anyone to take analysis and work on this space. Technology has gotten us to a point in which we have Earth data, which is big data. There is nothing as big as planetary data that requires huge compute, big compute, the type of compute platform that is available through cloud technologies. And also we have advanced the algorithms. There is a lot of advance in deep learning neural networks that help us, get sophisticated solutions to classify things or forecast things. And advanced statistics. Climate modeling, for example, is a perfect example on how big data uses big compute to get us to understand the Earth systems. And more, we are seeing very sophisticated remote sensors that from space are helping us observe Earth to help us understand more about the dynamics, complex systems that Earth runs on. And I'm no longer working for Microsoft, but I wanted to tell you a little bit about the planetary computer, because if you have not taken a look at it, you should. You can get access to more than 50 petabytes of data, and you can also get a compute hub to your disposal. All you need to do is create an account for free, and you can start learning about the algorithms through Jupyter notebooks. The platform is built on open source and the work of the community, and uses, Pandu, for example, as a distributed compute platform that climate scientists are using today. So if you have not seen it, just take the time and peek if you work in this space. Some examples of the work that have resulted of planetary computer, for example, is this 10-meter annual land cover map created by Impact Observatory. This model is annual and it has data as of 2017, and it's going to be updated annually. We have right now 2017 to 2022. And there is nothing more important than land cover mapping to understand how we are changing the landscape. And this deep learning algorithm was trained on billions of pixels that have been labeled by humans. This same data set is explorable through S3 Land Cover Sentinel-2 Explorer, which is the same data set, but allows you to interact with it dynamically. I believe that the image that you're looking here is the Monarca forest. I think I got that one. And you can see, for example, the comparison on how the land has changed in 2 different years, in this case, from 2017 to 2022. And you can see that with the swap view, or you can create a time-lapse video that shows how it has changed over time. You can see the land cover, and you can inspect also the image, and you can see the different classes there. You can isolate one particular class, say, built area in its own. So it is really a great tool to explore, a particular region, and it's global at 10-meter resolution. Another example comes from NGO Amazon, who created a deforestation risk prediction tool in the Amazon, also using Sentinel-2 imagery. It turns out that illegal roads are the best predictors to detect deforestation in the Amazon. This solution allows the deforestation risk to be predicted 3 months in advance before it occurs. Information from this tool is provided to policymakers in Brazil to help protect this important ecosystem. Previsa is the name of the tool. Another great tool, to go along with Global Forest Watch is the UN Biodiversity Lab 2.0. It is a tool that has more than 400 cutting-edge data sets, all integrated in one single tool for you to be able to aggregate information. And it was created to allow for governments to create plans for the protection of biodiversity and achieve the biodiversity 2030 targets. It's a great tool, and it's also free of charge. I am going to now to shift to climate change and the vulnerabilities that our ecosystems are facing. We have increasing temperatures in the globe, and we are also seeing different patterns of precipitation. These are creating extreme weather events that are occurring more frequently and more intensely, and those are causing havoc to our ecosystems. The environment is changing. For example, the water conditions of our forests are changing. The water flow from river changes so much. Here in the Washington state in the US, for example, the snowpack is diminishing, which means that it runs off in the spring, and in the summer is causing a severe drought of our ecosystems. We have sea level rise taking wetlands, and we have drought really putting at risk a lot of our forests and crops. Extreme flooding events, and what can we say about wildfire? For example, I'm sure that all of you have heard that Canada has seen the worst wildfire season in record in all its history. And when there is warm weather, there is the incidence of invasive species and insects that are also taking a toll in our forests. So these changes are going to cause chronic risks, which are shifts in the environment in long term, and they're going to cause acute risks, which are event-driven, short-term, term-driven events with high mortality for our forests. What is the future of our climate? Well, we have an excellent scientific body of work in IPCC, the 6th report, and CIMIP 6. The scientific body has taken the data and information and modeling of Earth to create 5 different future scenarios. And these scenarios have been created with different actions that humans can take. Either we take the sustainability road and we have the scenario for SSP1, or we go to the extreme with the scenario where we adopt fossil fuel development and growth. And we can see here the different temperature variances that we can see in different scenarios. But what is important is to know that IPCC scientific work group has created these climate projections, and this data is available to all of us to leverage in our adaptation plans. We don't know what the future is going to bring, but we have to be able to understand what the extremes are going to do so that we can plan better for the future. Global climate models are created at the continental scale, and they are very coarse. The resolution is about 200 by 100 kilometers. But when we need to do local analysis and climate risk assessments at the local level, we need to have finer resolutions. Therefore, we have downscaling processes that take climate data models and downscale them to better resolution so that we can do that analysis at the local level. In this example, for example, the island that you see here is Tasmania in the South Australia area. And in the climate model, you see that Tasmania is completely brown, indicating that it's going to be, under drought. But as you start increasing the resolution of this information, you can see that at 10-kilometer resolution, the western side of the island is going to be under drought, while the eastern side of the island is going to have more precipitation than normal. So downscaling climate models is one important step for local risk assessments. There are different methods that you can do that render different results. And that's why I wanted to point out to the work of Carbon Plan. They have created an open data platform that takes different methods for downscaling global climate models so that you can compare the results and you can find perhaps the best model for your needs. You can explore the results in a dynamic map. In this case, you see on the left-hand side the coarse results of the global climate model, and on the right-hand side, the downscale high resolution map. And the idea is that you can use these downscale models to create impact models that can take a look at fire risk or drought risk or flooding, and you can create impact assessments with those models. All of this is open source and available on GitHub. And this is just an example of the interactive tool where you can see here precipitation for the scenario SSP5 on this particular, model. So you can, zoom in, get the results, see the data, and compare the results with other models. It's important work that we all very quickly need to learn on how to do this downscaling so that we can do, climate risk assessments. And an example of an application using downscale models is another Carbon Plan application that got done for forest risks in the US. In this map, you can model 3 different climate scenarios, and you can see on orange the risk to fire, on pink the risk to drought, and on purple the risk of insects. And you can, get to see that on the time scale, so we can understand what the future of the forests in the US is going to be. Now, let me switch to another area that is resulting in an acceleration of risk analytics, and that is investors understand that climate change is financial. Climate change risk is financial risk. So corporations are required now to disclose the climate risk financial disclosures and the nature loss financial disclosures, the frameworks of TCFD and TNFD. And why it's important to this conversation is because there is a lot of risk analytic tools that are becoming available for doing this type of assessment that could be used for risk impact for our forests. I had the pleasure to work with Earth Knowledge for the last 3 months, and they have created a 1 kilometer digital twin of Earth that has 4 future climate scenarios, and it is at 1 kilometer resolution, a high resolution that we need to have in order to understand our risk to climate. And they are modeling 50 indicators on these themes, on drought, ecosystems, flood, precipitation, temperature, water, and wildfire, so that you can understand at the very local level what is your risk of, say, increased precipitation or flooding or high temperatures. This is the type of tools that we can leverage, and there is, many providers doing this type of work, so keep an eye on those. Now, for the last topic, I want to talk about the domain of climate in forests and climate change. This picture tells us the relationship between temperature and precipitation that helps us classify our forest biomes, right? Low temperature, low precipitation, and you have the tundra, while you have high precipitation, high temperatures, and you have the tropical rainforests. It is understood from IPCC that we are going to see a shift in biomes in some parts of the world. These are the predictions from different authors to what percentage of Earth will shift a biome. And this brings us to the topic of climate analogs for future predictions. I wanted to introduce the work of Conservation Science Partners, one of my favorite organizations that are working with forestry in the US to precisely understand after a fire has happened. You have to have a choice of what species of trees you are going to plant. And now we need to understand what is the climate going to be in the future for this region so I can plant the appropriate tree. Is the native species still good, or do I need to shift to a different type of species so that it can survive the future climate? In my home state in Washington, for example, we are no longer planting Washington species. Our forests right now are being reforested with trees from California species because our climate is going to look like California a few years from now. We need to have more drought-resistant trees. So this is at the cutting edge of conservation and forestry. And I just wanted to drop, a note here. This is the published paper from Conservation Science Partners on climate analogs. We have a lot of work to do, so all works on hand to help us address one of the hardest problems humanity has. And all I wanted to do is leave you with this beautiful Earth observation of my 2 favorite volcanoes in the world. So thank you very much.
Pues muchísimas gracias, Alma. En verdad, para nosotros es muy importante que nos expliques detalladamente cómo es este proceso y cómo el paso a paso para poder realizar este tipo de proyecciones futuro. Y qué padre que también de ese lado también ustedes lo estén realizando, pues porque al final pues hay tecnología que realmente desconocemos, ¿no? Y que actualmente podemos utilizarla a nuestro favor y que por este medio, pues nosotros hacemos promover este tipo de tecnologías, ¿no? Para que pues obviamente sea una aliada para para la conservación de nuestros bosques, de nuestros recursos naturales y de nuestras, tanto en el sector forestal o ambiental. Entonces, pues muchísimas gracias, Alma, y vamos a ver si hay alguna pregunta, si tienen alguna pregunta, alguna duda sobre la presentación de Alma, pues con gusto aquí lo vamos a ir viendo. Pues bueno, creo que al parecer nadie tiene dudas, pero si llegaran a tener algunas preguntas, nosotros se lo haremos pasar, te lo haremos pasar a ti, Alma, sin problema. Y información, bueno, dice Lili que información de mucha ayuda, muy clara la participación de la ponente. Entonces, pues muchísimas gracias. Te agradecemos muchísimo por esta participación. Realmente esperemos que el año que viene, esperemos otra edición de este foro, pues también tengamos más actualizaciones de lo que tú nos presentes. Entonces, pues muchísimas gracias.